Hi friend, here in this lecture we're going to learn about Docker, which is a very interesting technology because it is used for all kinds of software development. It can be used for developers, testers, and operation managers to ship various versions of your applications, which allows you to easily develop, deploy, and ship your applications. It could be used on the cloud or with on-premise or other resources. So let us understand what is Docker. Docker is a platform for designed for to make it easier to create, deploy, and run applications in the form of containers. Containers could be visualized as a certain thing that is being used for shipping various equipments. Whenever you order a certain product online or from buy a certain product from any store, being it mall or other places, it may be shipped using a physical container, uh, using the container ships or more from one to another country. Similarly, we have the containerized applications on the cloud or with the software industry as well. So Docker allows you to develop for it allows developers to package up applications with all the parts it needs, the library functions and different tools with the containers and ship it out as a single package. So for developers, it means that they can focus on writing code without worrying about the system that it will ultimately be running on. Be it a platform, they can think about coding or a product more than the installation, configurations, and different things. If your applications is developed for Windows and you have a Linux, so you don't need to waste time to implement it on Linux. It will be ultimately been running on. It also allows them to get a head start by using one of the thousands of programs already designed to run in a Docker containers as a part of their application. For operations staff, the Docker gives flexibility and potentially reduces the number of systems needed because of the small footprint and lower overhead. It does not require the guest operating system and the hypervisor. We're learning about these two things. So when we have a Docker file, we can build an image and the image could be executed on the containers. So who is Docker for? Docker is a tool for all kinds of developers, system administrators, testers, and anyone who is part of a DevOps team. The containerized container image becomes containers at runtime, and the core of the Docker containers, the images become containers when they run on a Docker engine. So we have the containers, we have the Docker image, and they are executed there. Container images are executed with the help of Docker engine. So we have two components. It is available for both Linux and Windows based applications, and containerized software will always run on the same regardless of the infrastructure. So we don't need to worry about the Linux or Windows or other system utilities. It could be deployed without any worry. We have the Docker engine that could execute everything. The containers isolate software from its environment and ensure it works uniformly despite differences, for instance, between the development and staging. So it is a very powerful tool as well. So here is a virtual machine. It was a predecessor of the containerized applications. Virtual machines are very powerful, and the containers are different thing from virtual machines, but they could be used in different scenarios. Say you have been using virtualized environment at some point of the time. You might be using a virtual box or VMware on your personal computer to have multiple operating systems simultaneously running on a single computer. Say when you want to run Linux and Windows simultaneously on the same screen, the same computer at the same point of time, you could create a virtual image for any one of them and host it on a thing. Virtual machines are abstraction of the physical hardware running on a server into many servers. Virtual machines makes use of a hypervisor, which is a special program that allows multiple virtual machines to run on a single machine. Each virtual machine includes a full copy of the operating system, the application necessary binaries and libraries. It could take up to tens of GBs, and virtual machines can be slow to boot as compared to containers. So here is the environment of virtual machines. We have each guest operating system for each applications or each instances of virtual machines, and we have multiple applications for different machines. We need to install a special program called hypervisor for this purpose. So it will be additional overhead on the system to perform various tasks using the virtual machines. So now moving ahead with containers. Container is a special application which is an alternative to virtual machines. It could be container images become containers at runtime, and in core, the Docker containers, the images become containers when they run on the Docker engine. So containers are a standard unit of software that packages up the code and all its dependencies. Here we don't have any guest operating system or the hypervisor. It could be run quickly and reliably from one computing environment to another. So Docker container image is a lightweight, standalone executable package of software that includes everything required to run the application. It consists of code, the runtime, the system tools, system libraries, and the settings. It could be it could consist of different versions, the standard, the lightweight, and secure. Docker created the industry standard for containers, so it was the first to move ahead in this field, and multiple containers are there based on the standards. So they could be portable anywhere. So lightweight, it is lightweight. The containers share the machine's operating system kernel and therefore do not require an operating system per application. So it is higher server efficiencies. It provides reducing the server and licensing cost as well. So it is lightweight, and you don't need to have multiple instances running simultaneously. Then you have the security feature. The applications are safer in containers, and Docker provides the strongest default isolation capability in the industry. So with the containerized applications, we don't have any hypervisor or the guest operating system. We have multiple applications running there and have the Docker engine being supporting that thing. So Docker consists of basically two things. We have the Docker engine, the Docker Hub. So the Docker engine is a portable, lightweight application or runtime and packaging tool. It supports the Docker images being executed here. Then we could have the Docker Hub, which is the cloud service for sharing applications and automation workflows. So we could have Docker images supported on a Docker Hub as well. So there are multiple daemons or things that being executed. So we at the core we have the server consisting of the Docker daemon, which is a process running to support the Docker. Then we can have the REST API to connect the client and the server, where the client uses the Docker command line interface, having multiple commands for managing different things. We could manage containers, images, data volumes, and the networks using the client Docker command line interface. The Docker containers differ from the hypervisors in multiple cases. In both cases, we have the library functions and applications installed. Both have the server and the host operating system. The difference is, in place of hypervisor, we have Docker engine, and we don't have any guest operating system in the containers. However, when you require a hybrid solution, you could integrate both virtual machines and Docker in order to produce a hybrid scenario. We may have when you have non-Linux environment, the host operating system is not Linux, or say Windows, and you want to support Linux applications along with the Docker engine. So you could create a guest Linux as well and have the hypervisor. However, this solution is not preferred because it is a heavyweight process, both more than the containers and virtual machines itself. So you could use either the Docker container or the virtual machines. The Docker Enterprise Platform consists of various key components. It has the container engine for Docker. It has the platform security options. It is used for developer services. It consists of registry services. It has the access policies, it has the app lifecycle management tools, it has the automation and extensibility options, it supports the networking, the orchestration, and the storage options, and it could be deployed on the cloud, integrated with virtual machines, uh, installed on the bare metal systems, or connected to the edge devices. Docker could be used to push images to the Docker cloud. Uh, it could be used to send different triggers that could be generated using the serverless applications like functions or Lambda on the Azure, on the AWS. That could be integrated with database, installed with different plugins or tools like that, and they could generate the notifications based on which multiple instances or images could be deployed on the cloud. So this was about Docker. You can build your container, deploy it on the cloud. Try building your own solution. Till then, keep learning and keep moving ahead.